We'll see my thing is.
Yeah, and that's.
So that's the final vertex.
Yeah, yeah.
This
So,
is
isn't that what you sorted in there?
Sort of. Oh, you're doing least square code. So negative b, negative 10 over twice negative 1, I get positive 5. And now throw 5 back in,
less than 10.
and that'll give you the area.
Negative b over 2a gives you the.
Problem right here.
Well, because it's asking what
Yeah.
the maximum area is,
Uh-huh.
so we're looking more for range, I think. We won't get a specific answer because we'll have a variable.
But see, you subtracted 12 already, so you better add 12. Undo it. Negative 3 times 4 is negative 12. So you better add 12. Yeah. Makes the vertex a little less out there.
I'm not too sure if this is going to go down to.
All right, guys, let's take a look here. All right. So this first part, I don't ask you for much. So like on a test, don't waste time doing more stuff than I ask. Right? Sometimes I just want to make sure you know a certain skill at a certain time. So here, what's the vertex for this guy?
2 and negative 1.
Yeah, 2, negative 1. I love it. And will it open up or down?
Up.
Because the 3 is
Positive.
positive. I like it. Up. It looks like that. Yay! Done. What's this guy's vertex?
Negative 5.1.
Negative 5.1.
13.
13. And then it opens
Down.
down because that guy is there. Cool. Okay, good. Now this guy is nice because it has a 1 out front, so it should be a little easier. So I get x squared plus 6x, leave some room, plus 6.
Plus 9.
Yeah, half of 6 is 3 squared. Is 9. So if you put plus 9 there,
Minus 9 on the outside.
put minus 9 there. So you end up with f of x equals.
X plus 3 squared. Minus 3.
Good. So the vertex is negative 3, negative 3. The y-intercept we knew from the beginning.
0 and 6.
0, 6. And I kind of, I like this way better. We could find the x-intercepts, but really I don't need them for the graph. I don't. And I want to make my graph, I want to be a little bit smart about how I do my graph. This one you might not realize ahead of time that you need to be careful. The vertex is at negative 3, but you have to go equidistant on the other side, so it's better to make everything have a scale of 2. So like 2, 4, 6, 8, 10, negative 2. Negative 2. So then the vertex is negative 3, negative 3. So it's like right there. Plop. The y-intercept is 0, 6. So there's going to be another point the same distance away on the other side. Is that? So since I'm at the vertex is at negative 3, it's 3 away, so it's going to be another 3 away, it's going to be there. That's the point we got by symmetry. I love how you guys are all pained expressions, but please let that just make sense. Here's the mirror. The mirror goes through the vertex. So if there's a point 3 away on that side, there must be a point 3 away on that side. That's it. Yes?
I think it's easier just to call it the law of symmetry.
Oh.
The law of symmetry. So that way because I think axis is just a harder word to really grasp.
Okay. But the axis is an actual line.
Mm-hmm.
Just like the y-axis and x-axis.
Yeah.
Okay, I like it. It's not a law. Yeah, so it's the physical thing. It's not the law of symmetry, it's the axis of symmetry. The actual physical thing I just drew is an axis. It's not an x-axis. It's not a y-axis. It's a symmetry axis. Cool, I like it. And so here's the parabola. You just got to connect the dots now. And just, the funny thing is sometimes people will plot the vertex and then they'll have it not be the turning point. So whatever the vertex is, you got to make sure that's the actual place where it turns. Right? I'm not picking on anybody. And I don't know if you guys, anybody did this. What is the equation of that line? That axis?
X equals -3.
X equals -3. Yeah. How do I know that? Because what is the x value at the vertex?
-3.
And the vertical line is x equals, so x equals -3. So what's the axis of symmetry for any parabola going up or down? X equals the x piece of the vertex. That's the equation of the axis of symmetry. Sweet. So any questions on that problem? How's that going? So it's real simple to make a mistake like getting a 15 in there or something. I mean, that kind of mistake is easy to make because you're just not used to doing everything on one side of the equation. So instead of thinking, do the same thing to both sides, you have to undo what you just did if you're working on one side. So what about this guy? What do I have to do first on this one? Yeah, take the 3 out, the -3 out of the x stuff. Be a little careful about, what's this?
-4.
Minus 4x, I like it. Leave some room. So now what do I have to put here? Half of -4. -2 squared is 4. So what did I actually just do?
Subtract 12.
I subtracted 12, so I better add 12. So I end up with x minus 2 squared plus 5. I like it. And you know, this is actually a way you can check yourself. What's the y-intercept from this?
-7.
0, -7. So what's the y-intercept got to be from this? It's got to be the same thing, right? Because they're the same. My claim is they're the same. So it's actually a way to check it. Plug a 0 in. -2 squared is 4 times -3 is -12 plus 5 is -7. Thank God. So that is a way to check to make sure that the standard form came out right. Let's see, what else did I ask for? Oh, that's it. So the vertex, we can see it, but let's write it down.
2, 5.
Yeah, the 2, 5. I love it. I'm glad nobody's worried about if this guy, the inside doesn't give a shit what's out here. So I'm loving it that I don't hear anybody saying, well, I did the negative. No, because it doesn't have anything to do with what's on the inside. I like it. So looks like the y-intercept is -7, so we might as well do by 2's on the y-axis here. Just do -2, -4, -6, -8. 12, 6, 8. Here I'm just going to do 1, 2, 3. You can almost get it there, Jeff. All right. So 0, -7 is my y-intercept. 2, 5 is my vertex. Plop. So where's there going to be another one? It's got to be 2 away in the other direction, so it's got to be right there. Now, can somebody come up with a way to check that? How do I check to make sure that point is actually on the graph?
You make the y value equal, and then plug in the
Yeah,
x
what
value.
point is this?
4 -7.
4, -7. So when I plug a 4 into this, the answer better come out to be
-7.
-7. It's actually a little easier to use this one. 4 minus 2 is 2 squared, is 4 times -3 is -12 plus 5, -7, yay! I mean, so how do you always check to make sure that a point you found is actually on the graph? You just make sure it works in the equation, because that's what a graph means. It's all the points that work. So now everything's checking out, because this thing is supposed to open down, and thankfully there's my vertex, and sure enough it does open down. Would you say that this point is a maximum or a minimum?
Maximum.
Yeah, it's the tallest point, so it's a maximum. So when it opens down, the vertex is the maximum. When it opens up, vertex is a minimum. So this could be like a profit function, and this is thousands of computers, so we got to sell 2,000 computers to make the biggest profit, for example. And this could be like a cost function. It's in the negative, so screw it, it's not really useful. But This would be something you would want to keep minimum. Okay. So when I reference the shortcut for the vertex, I mean what? Yeah, negative b over 2a. Love it. So what is b?
8.
8. It's always a number in front of the x. And what's a?
Negative 2.
Negative 2. So I end up with
2.
2. And then to find the y value, I just plug that sucker back in. Negative 1? Is that right? Sounds like it, John. Yeah. Okay. So this 2, 1, this value, is it the max value or the min value? Well, which way does this sucker open?
Down.
Down. It opens down. That would be here. It's going to be the biggest. So the biggest output of this function is 1. Poor little function. But how big of a negative output does it get? As big as you want. Because it goes down forever. I like it. That's one of the wish button. Sort of draw a slide. All right. So I'm trying to build you in the right direction with these worksheets a lot. So I had basic stuff that we've done together. Then I had something with max or min in it, which is a different kind of word, but I was hoping you might be able to tease out what I meant, the top of the hill or the bottom of the valley. And then I got sort of a word problem, sort of. Or I've done most of the work here for you, to be honest. So I've got a triangle. Rectangle. Yeah. Well, at least I drew a rectangle. Got a rectangle, one side is x, the other side is 10 minus x. What is the area of that rectangle going to be? What's the area of any rectangle? Length times width. Yeah. So it'll be x times 10 minus x, which is 10x minus x squared. Now, all this earlier stuff is leading you in this direction. I want the maximum area. Why does it make sense there will be a maximum to this? Because this parabola opens down. I love you guys. If I said y equals 2 plus 3x, is 2 the slope? No, the slope is in front of the x. So where's the a? The a is in front of the x squared. A is negative. Opens down. This is just written, you can write it in order if you want to. Negative x squared plus 10x. There you go. I like it. So if I find the vertex, I will find the maximum area. Because the vertex is the location of the maximum, because the sucker opens down. So how do I find the vertex? I didn't say you have to put it in standard form or anything. If I just want to find the vertex, negative b over 2a, please, dear God, that's the quick way to get it. So what's b? 10. What's a? Negative 1. So your x is 5. And the question is, what's the max area? Well, then, incredibly enough, I put 5 into the area function so that I'll get an area. So when I put a 5 in, I get 10 times 5 minus 5 squared. 25. Now, in general, to create a rectangle that would have the biggest area, you always make it a square. If you're going to use all 4 sides. So there is a problem that's interesting. I don't even know where my camera is. There it is. Let me do it over here. There is a problem in the homework, and this is a classic, classic problem. Classic. You have a river, and you want to put something in a pen that's scared of water, I guess, right? You're going to pen up some vampires, and you use the old vampire rules. They can't cross running water. So you're just going to have garlic walls on all 3 sides, and then the water over there, right? You with me? So I'm not using all 4 sides. This is one situation where the answer won't be a square. I really want to make sure. Does everybody understand what happened? The answer here was a square. So the area, the biggest area is 25, but what would the shape be? 5, 5. It's a square. It will always be a square if you use all your wood or whatever for all 4 sides. The really neat thing is, this sucker here, let's do this problem. Let's say I have, what you got, Jeff? 30 feet of fencing, garlic fence, to make this pen for my pet vampire. Sorry. I do this for myself. I get a kick out of it. So if I want 30 feet of fencing, well, how wide will it be? I have no idea. So X. Let me see if you guys can get what this is going to be. If I want to use 30 feet total, how many feet have I used so far? How much?
2x.
2x.
Yeah.
So what do I have left? 30 minus the 2x I've already used. And what's the area of this? What's the area?
X times 30 minus 2.
X times 30 minus 2x. So 30x minus 2x squared is equal? Just stay with me. Stay with me. Now to find the vertex, which will be the maximum area, because I want to give them a lot of area to run around in, right? Hopefully they don't change into batches, fly over my pencil. Sorry. So x will be negative b. What's b?
30.
30. Good. Negative 30 over twice a. 30 over 4. Right? 15 over 2. So 7.5. 7.5 feet. So that's 7.5 feet. How long is this side? 30 minus twice 7.5. 30 minus 15. 15. Notice this is really neat. I don't know if you guys are going to get this. So it's not a square, but do you see how these together and these, this doesn't even exist, but these together are 15 and these together are 15. It still kind of comes out square in some weird way, to be honest. And there are other problems you can do where you have different costs for different sides, and it'll still come out to be a square in terms of the cost. It's interesting. All right, that's enough of that, sorry. So there are the problems like this. I would highly recommend you draw a picture. There's also, you have the back of your house, and you're going to make a pen off the back of your house, so you only have to use wood on these sides. It's the same problem, right? Same problem. I like it. So I'm warning you, that's in the homework. Okay. Everybody got a practice test, right? All right. Let's see. Is there anything else, Jeff? There are 2 sections left in chapter 11, and to be honest, they are just extensions of stuff that we did in earlier sections in 11. So the more sense 11.1 through 11.4 makes, the more sense 11.5 and 11.6 are going to make. Let's see. I do have a little bit. It's all right. Let's do one example problem from 11.5 and let us out of here. Still kind of early anyway. So I'm going to show you a method that'll work no matter if it's squared or cubed or fourth power or whatever, as long as you can factor it. So the method requires you to factor. So we did this kind of problem before already in one certain way. Think about the graph of this. But I want to do this more directly algebraically. How do I factor this? X minus 9, x plus 3. So really what this is saying is I want the result of this product to be negative. Do you see that? I can't just say that less than 0 or that less than 0 because, I mean, it doesn't make any sense. I could do all these different cases. How do you make something negative? That's 0, that's negative and that's positive, or that's positive and that's negative. Well, why do all that shit to yourself? There's a beautiful way to do this. Where is it 0? Where is it equal to 0? 9, negative 3. That's where it's 0. So I'm going to put a little z up there for 0. It's crazy. Now think about it. If I have a nice function just flying along, see it's positive right now? See how the function, oh, it's all positive. Aww. What's the only way it could become negative? It has to go through what? There's no other way for it to do this. It's got to go through what? It's got to go through the freaking x-axis. It's got to have a 0. I call that a door. If there's a 0, that's a door from one side to the other side of the x-axis. So what the shit does that mean, Jeff? That means that if I plug a number in like 0, see how 0 is between those two? If I plug a 0 in, don't I get a negative? It's going to be negative all the way through that whole thing. Because the only place it could change sign is through a 0. That means it's going through the x-axis to the other side. So if I plug in 10, what do I get? 10 minus 9 is positive. 10 plus 3 is positive. Positive times positive is positive. So when you put your zeros, you're kind of breaking this up into regions that you have to investigate. How do you do that? You just plug a point in from them. And you know it's going to have the same sign through the whole region, because those are the only place that could change signs, through the doors. So what do you get when you plug a negative 4 in? Negative. See how I don't even give a shit what the number is. Negative 4 minus 9 is negative. Negative 4 plus 3 is negative. Negative times negative is positive. So how do I answer the question? Well, now I just stand back and I say, where is this thing less than 0? Where is it negative from negative 3 to 9? Not including those, right? Because that's where it's 0. If this would have been less than or equal to, I would have put brackets on them. If this would have been greater than, I would have said negative infinity, negative 3, and then 9 to infinity. Because I could just see where it's negative, where it's positive. That was remarkably quick. I don't expect you to get it fully from that. But if I had another factor out here, I would have just put another door on here. It would have just been another region to check, and I would have done all the same shit. It's kind of nifty. All right. I managed to pack a lot. Hopefully you guys are not concerned that we keep leaving early. I think you're fine with that. But you don't ask much questions, so I managed to pack a lot in there. So we're good to go. That's as much as I wanted to talk about today.
Am I going to be able to take my break today?
Yeah, you come back to the office.
Okay.
Did somebody turn in 7-6 homework? There's no name on it.
Do you want us to focus more on like 11, 1 through 4 homework, so we're not really going over the, like section 5 and 6?
We are. We're going to do that next time.
Okay.
Mm-hmm. When you took a negative 3 out, that should become minus 12. Minus 4, actually. Minus. Yeah. And then it would have been a minus 2.
Can I see some 6 homework you were talking about?
Oh, No. I'll put it back in the pot here. I don't think this is you, is it? No.
No.
No. Okay. So, remain a mystery.